No, in the last video we talked about the speed, velocity and acceleration and also distance time graph. Now this video is about velocity time graph. So if we consider an object moving from O to A, now, and this is velocity, now it starts from rest, its velocity is 0, then it reaches a velocity of 40 meters per second, and it takes 10 seconds to do that. So we say that the change in velocity from 0 to 40 and divide by the time, which is 10 seconds. In other words, the object is accelerating from O to A, is accelerating, and this acceleration is uniform because the graph is a straight line. Its velocity changes by equal amount in equal intervals of time. Therefore, it is uniform velocity. So we can say that from O to A, we have constant it's constant acceleration. Its speed is changing, so it's constant acceleration. Constant or uniform is the same thing. Now it's constant acceleration. Now how can we find the acceleration? The acceleration is the change in velocity, which is from 0 to 40. So the change in velocity is 40. And the time taken is 10 seconds. So change in velocity is 40 and the time taken is 10 seconds. So we can say this is 40 divided by 10, which is the same as if we take the gradient of the graph of line OA. So this is equal to 40 divided by 10, which is 4 meters per second squared. Now, remember this is same as the gradient of the graph. I can write gradient of OA, right? Gradient of OA is given by the acceleration. Now from A to B, what's happening from A to B? Now, the car accelerates, the body accelerates from 0 to 40, it takes 10 seconds, and then after that, the graph remains horizontal. Now horizontal means it stays at this speed, it reaches a speed of 40 meters per second, and it stays there for the next 20 seconds, okay, from 10 to 30. So this is 20 seconds. Okay, it stays at the same speed, and then from B to C, the speed decreases from 40 back to 0, and it only takes 5 seconds to do that. So from B to C is deceleration. So from A to B is constant velocity, and B to C constant deceleration. Now, which one is greater, the acceleration or deceleration? Now, as you can see, the gradient of the graph here is shallow. Okay, this one is much steeper. That means the velocity is changing much more quickly. It's only taking 5 seconds to change from 40 meters per second down to 0. So the deceleration is much greater because it has a steeper gradient. So we can say the deceleration is the gradient of this graph. This is 40 meters per second. I can write meters per second, and this is seconds. This is 5 seconds, that's meters per second. It's 40 divided by 5. Which is 8 meters per second squared. Now you can see that the acceleration is, here it was 4 meters per second squared. Now the acceleration has doubled, okay, because the time is halved. So it's slowing down much more quickly. So the thing to remember is that the acceleration is given by the gradient of the velocity time graph. So I think we can make a note of that. It's important. Acceleration is the gradient of velocity against time graph. Okay, just remember that acceleration is the gradient of velocity time graph. Now, the next thing that we're going to talk about is how do we find the distance traveled? So, distance traveled can be found by, no, if we consider it's moving, no, remember, speed is equal to distance divided by time. So if I rearrange the formula, distance equals, or instead of speed we say velocity, is equal to velocity times by time. So distance is equal to velocity times time. So if we go consider from A to B, the velocity is 40, the time taken is 20, so the distance traveled will be 40 times 20, which is the same as if we find the area under this rectangle. Okay, so this is same as the area of this rectangle, okay, will give us the distance. So if I find the area of this rectangle, I can draw this line fully. I'm going to call this area A, area B, and area C. Now, the distance traveled from O to A will be the area of this triangle. Okay. Now remember, it's going from 0 to 40. So the because it's accelerating, its average velocity will be 0 plus 40 divided by 2, and then times by the height, which is times by the time, which is 10. This is same as if we say half base times height. Okay. Now the distance traveled is given by the area under the graph is equal to the area under velocity time graph. Okay, so from O to A, we say distance equals area A. Now area A is a, I can do the shading in a different color. Now area A is the area of this triangle, which is base times height divided by 2, or half base times height. That's equal to a half times 10. The base is 10 and the height is 40. A half times 10 times 40, which is 200 meters. Right, half of 10 is 5, 5 times 8 is, 5 times 40 is 200. Now, from A to B, distance is equal to area B. Now, this is the area of a rectangle. The rectangle, the area is base times height. Base which is 20 and the height which is 40. So we say it's 20 times 40, base which is 20 times 40, which is equal to 800. Now, while it's accelerating, it travels a distance of 200 meters. While it's going at a constant speed, it travels a distance of 800 meters. Now, how much distance does it travel while it's decelerating? From B to C, the distance is equal to the area of C. Okay, area C is, again, a triangle. The area of a triangle is base, which is 5, and the height, which is 40, which is a half of base, a half times 5 times 40. Half of 40 is 20, 20 times 5 is 100. So it travels a distance of 100 meters. So the total distance traveled is going to be equal to the sum of A plus B plus C. So we add all these together, which is 200 plus 800, 200 plus 800 plus 100. And that comes to 1100 meters. So we find that the total distance traveled is 1100 meters. Okay, now we could have found this distance by actually finding the area of the whole trapezium. Now this is from OABC is a trapezium. Now I can just show you that we could have found total distance equals area of trapezium. Now this trapezium OABC. Right, now if you remember the formula for the area of a trapezium, it's the average length of the two sides, okay? It's this plus this and this, divided by 2 times by the height. Now this length is 20, that's 20 seconds, that's 20. This one is going to be from there to 35, so that's 35. 20 add 35. So we say that area equals 20 add 35, divide that by 2, and then times by the height. The height is 40, times by 40. No, 20 add 35 is 55, and I can cancel 2 into that, goes once, that gives you 20. 55 times 20, 55 times 20, which is 1100. Okay, now this gives you the same answer as if we find the distance separately. Now sometimes it's easier, if they ask you to find the total distance, it's easier to just find the area of the trapezium and they'll give you the total distance straight away. Sometimes they ask you what's the distance traveled while it's accelerating or while it's going at a constant speed. Then you can do it separately, okay, like this. Okay.